In topic 3, we are going to be introduced to negative exponents. And the main thing we have to know about negative exponents is what a reciprocal is. So let's look here. A reciprocal is two numbers with a product of 1, meaning when we multiply the two numbers, it equals 1. And it's really easy for us to get the reciprocal of a number. Let's say I give you the number 2. The reciprocal of it would be 1 over 2. All we do is we flip it into the denominator, because if we multiplied these two together, 2 times 1 over 2, that would equal 2 over 2, which is equal to 1 if we reduced that. Because remember, this 2 here has an invisible over 1 underneath it. So we would multiply the numerators, so 2 times 1 is 2. And then we would multiply the denominators. 1 times 2 is 2 as well. Sorry, 1 times 2 is 2. So here I'll give you another example. If I gave you 1 over 5, the reciprocal of that, we would flip it, so it would be 5 over 1, or just 5 would be the reciprocal. So then if we multiplied those two together, 1 over 5 times 5, and then it has the invisible over 1, we would get 5 over 5, which is equal to 1. So those two are reciprocals. And finally, if we had 3 over 4, the reciprocal of that would just be flipped, so it would be 4 over 3. Because if we multiplied these two together, we would get, well, 3 times 4 is 12, and 4 times 3 is 12. So our final answer would be 1 if we reduce that. So all of those are reciprocals of each other. So now let's look at negative exponents. So here it's explaining our rule. If the exponent is negative, what we do is we take the reciprocal of the base number here, so the x moves into the denominator, and then our exponent becomes positive. That's what this is saying. So let's look at example 1 so we can see what happens here. Evaluate each power. So starting off with 3 to the power of negative 2. So whenever we see a negative exponent, our goal is to make it positive. And in order to do that, we need to take the reciprocal of whatever that base number is there. So to do it here, we're going to take the reciprocal of 3. So the reciprocal of 3 is 1 over 3. And now our exponent becomes positive 2. So now what happens is that exponent applies to the numerator and the denominator. So if I were to write this next step, it would be 1 to the power of 2 over 3 to the power of 2. And 1 to the power of 2, well, that's just equal to 1. And 3 to the power of 2 is equal to 9. So the final answer here would be 1 over 9. Let's try B. So B, we have a negative exponent of 3. So in order to switch that to a positive, we are going to take the reciprocal of the base. So we're going to flip that fraction. So instead of negative 3 over 4, we're going to have negative 4 over 3. Now keep in mind, this is a very, very common mistake here, is people will get rid of this negative sign here. And no, that's not the case. Okay, that negative sign stays, but the exponent now becomes positive. So that's the one that goes away. So now we're going to apply this exponent to both the numerator and the denominator. And I'm actually going to make this negative sign be attached to the 4, because we can write negative fractions 3 different ways. If we remember, we can write them as negative 4 over 3, so with the negative sign in the middle, or we can write it as negative 4 over 3 like that, or 4 over negative 3. All of these are equal to the same thing. So I'm just going to put that negative sign on the 4 on the top, just so it's easier for us to think about. So now we're going to have negative 4 to the power 3 on the top, and 3 to the power of 3 in that denominator. I'm going to put brackets around that negative 4 to the power of 3 because that negative sign is also included or affected by that power of 3. So now in the numerator, negative 4 to the power of 3, so that's negative 4 times negative 4 times negative 4 is equal to negative 64. And 3 times 3 times 3 in the denominator is equal to 27. And I don't think there's a way for us to reduce that, so here's our final answer, negative 64 over 27. Now for this last one here, it's a little bit trickier because now they gave us this decimal here. And I don't like dealing with decimals in pre-cal, but I do like dealing with fractions. So what I'm going to do is I'm going to switch this decimal into a fraction. So this is 3/10. So if we were to write this as a fraction, it would be 3/10, like so. And we would still have that -4 on the outside there. Now we need to get rid of that negative exponent, so we're going to take the reciprocal of our fraction. So it's going to turn into 10 over 3 to the power of positive 4. And now we're going to apply that 4 to the numerator and the denominator. So we'd have 10 to the power of 4 over 3 to the power of 4. And I know 10 to the power of 4, well, that's going to have 4 zeros, so it'll be 1, 0, 0, 0, 0, so 10,000. And 3 to the power of 4 is equal to 81. So our final answer for this one would be 10,000 over 81. Now in example 2, we are looking at negative fractional exponents. So now we're combining this topic with the last one. So the first step you're going to do is you want to rewrite this so that the exponent is positive. So what we're going to do is we're going to take the reciprocal of the base. So the reciprocal of 8 is 1 over 8. And now we can rewrite this with a positive exponent. Okay, then I'll write the little step over here. So the first thing, number 1, write with positive exponent. And the second thing we're going to do is we're going to apply that to the numerator and the denominator like we were doing before. So we have 1 to the power of 2 over 3 over 8 to the power of 2 over 3. And now our third step is we are going to change the fractional exponent into a radical. So remember, the denominator turns into the index. So on the top, we're going to have the third root of 1 squared. And on the bottom, we're going to have the third root of 8 squared. And then I'll just write this step over here. Change fractional exponent to radical. And now we would solve everything on the top or in the numerator and then everything in the denominator. So the nice thing about the number 1 in the numerator here is that it doesn't matter what the power is or what the root is, it'll always stay the number 1. So in the numerator, the third root of 1 is 1 and 1 squared is 1. So it always stays as 1. But now let's look at that denominator. Well, I know what the third root of 8 is. I know that is 2. And then we're going to have 2 to the power of 2. And then if we keep going, our final answer would be 1 over 4. Because 2 to the power of 2 is equal to this 4 over here. Now you could have also done 1 over, and you could have done 8 squared first. So 8 squared is 64, and the third root of 64 is also 4. So you get the exact same answer either way. Finally, let's look at this one here. 9 over 16 to the power of negative 3 over 2. So the first thing we're going to do is we need to write it with a positive exponent, and in order to do that, we need to take the reciprocal. So we're going to have 16 over 9 to the power of 3 over 2. So we take the reciprocal of only the base, only this part. We do not take the reciprocal of the exponent. That is a very, very common mistake with this. The only thing that changes with the exponent is that negative sign disappears. And now what we do is we're going to apply it to the numerator and the denominator. So we have 16 to the power of 3 over 2 over 9 to the power of 3 over 2. And now let's change those fractional exponents into radical signs. So this time, our denominator of our exponent is a 2, so that's going to be the index. So we're going to have the square root of 16 to the power of 3 and the square root of 9 to the power of 3. And remember, if we're taking the square root, we actually don't have to write this 2 here. It can be an invisible 2, but I'll keep it there just to keep things a little more straightforward. So now I don't know what 16 to the power of 3 is, but I do know that the square root of 16 is 4, so I'm going to do that part first. So the square root of 16 is 4, and then to the power of 3 is still there. And I know the square root of 9 is 3, so I'll do that first. So then we have 3 to the power of 3 in the denominator. So now 4 to the power of 3, that is equal to 4 times 4 times 4, which is 64. And 3 to the power of 3 is 27. So that is the final answer. And now finally, we have a word problem in example 3. So again, these word problems are just giving you formulas where you plug in numbers and solve. So let's see. Paleontologists, I don't know how to say that word, use measurements from fossilized dinosaur tracks, and the formula v is equal to 0.155 s to the power of 5 over 3 times f to the power of negative 7 over 6 to estimate the speed at which the dinosaur traveled. In the formula, v is the speed in meters. So here, let me highlight that. V is the speed in meters, and s is the distance between successive footprints of the same foot. And f is the foot length in meters. So there, they defined all the variables for us. So let's see what we have to figure out. Use the measurements in the diagram to estimate the speed of the dinosaur. So we need to find the speed, and they told us that the speed is v. So we're solving for v here. So let's see. We have our formula. V is equal to 0.155 s to the power of 5 over 3, f to the power of negative 7 over 6. So in order to solve for v, we need to fill in these other variables, or else we're not going to be able to solve the formula. So s is the distance between successive footprints. So if we're looking at the diagram they give us here, the distance between footprints is here, 1 meter. So s is equal to 1 meter. And f is the foot length in meters. So if we look here, they give us the foot length is 0.25 meters. So that would be the f. So let's plug that into the formula. We have 0.155. Our s is 1 to the power of 5 over 3. And the f is 0.25 to the power of negative 7 over 6. Now again, I don't like dealing with decimals in math, so let's see if there's any way we can simplify these into fractions. So I'll keep this first one the same, 0.155. But let's change this 1.00 into just a 1. Okay, so we have 1 to the power of 5 over 3. And I know that 0.25 is 1/4, right? Because that is, if we put that, that would be 25 hundredths, because that's the hundredths place value there. And if we were to simplify that, that would just be 1/4. So I'm going to switch that into 1/4. So 1 over 4 to the power of negative 7 over 6. So let's keep solving this here. So if we have a negative fractional exponent, the first step is to get rid of that negative sign. And in order to do that, we need to take the reciprocal of that base. So we're going to keep everything else the same here, but let's take the reciprocal of 1 over 4. So if we switch that around, that would be 4 over 1. And if we have 4 over 1, that's just the same thing as 4. So we have 4, and now this exponent is positive. So now that we have positive fractional exponents, let's turn those into radicals. So this 0.155 still stays the same, but now we're going to have the third root of 1 to the power of 5, and we're going to have the sixth root of 4 to the power of 7. So now, the nice thing about the number 1 is it's always going to stay 1 no matter what root we do or what power we do. So this is 0.155, and this is going to be 1, because the third root of 1 is 1, and 1 to the power of 5 is 1. And now, if I were to put this in my calculator, because I don't know how to do this in my head, okay, so this part here, this is definitely a calculator question. So if I plug into my calculator 4 to the power of 7, and then take the sixth root of that, we get 5.03 0.97 if we round it there. And now if we multiply all three of these things together, 0.155 times 1 times 5.0397, we get 0.7812 if we round that. And we're giving our answer here for V, which is meters per second. It says right here, V is the speed in meters per second. So right beside that answer, I'm going to put meters per second, and I'm going to box that up there. So that is our final answer. So questions like these really give us practice at working with formulas, plugging numbers into formulas, and also using the skills we learned with fractional exponents and negative exponents.